we're going to take a quick look at two pretty simple vector operations. They're not very difficult when we deal with vectors as numbers, numerical quantities, or the IJ notation. And they're not too difficult when we're drawing them, but it's kind of important to be able to know that they are interactive, and we should be able to sort of think about the other one that we're not working with at any given time. So we're going to do a quick little visual check of two operations. The first is addition. So if we had a vector u and a vector v, and we were supposed to add these geometrically or graphically, we could do what some instructors call the tail to tip or tip to tail method. You could draw vector u. We were going to assume that's the same direction and length as my picture above, but I'm thinking it's not 100% perfect, but we're going to assume it's there. And then from the end of vector u, we're going to put the same vector as vector v, which would be the same direction and magnitude. And that would be vector v. And then the sum of the two vectors that we're looking for here, the sum of those two vectors, is the vector that goes from the starting point of the first vector to the ending point of the second vector, in this case, right here. And that is the vector u plus v. There's a term for this when you were doing addition, when you add forces together. It is called the resultant. So that highlighted bold pink vector there, for those that can see it in color, that's called the resultant. Now, there's another way to represent this visually once you kind of know how the addition works, and that is if you have the original two vectors, u and v, and you were to imagine that these two vectors are the sides of a parallelogram. There we go. The diagonal from the lower left corner, my meeting point of the two vectors across, is that same resultant. That would be the u plus v vector, u plus v. And you will see throughout vector operations that parallelogram kind of plays multiple reoccurring roles. So you can't let it slip out of your mind that parallelograms aren't involved ever again. Okay, so that's the first operation, addition. So the second operation we're going to look at here is, what if we were to subtract the two vectors, u minus v? I'm having trouble drawing that little vector symbol here. Still having trouble. So there's u and there's v. And the way we can look at this is, instead of subtracting the two vectors, we can take vector u and we can add the opposite of vector v. And we've already seen that when you negate a vector or you multiply by a -1, that vector points same length but in the exact opposite direction. And so we could take the u that's drawn here, and then at this end we could take this end and we could draw the opposite of vector v. That would be -v. And then connecting the original starting point to here, that would be the vector. Now it's an addition, but this is actually the vector u minus v right here. Okay, now last but not least, remember vectors have the two quantities, the magnitude and the direction, that are important. Location of this bold vector we just drew could be anywhere on the screen so long as has the same direction and magnitude. So if we were to go back to our initial picture, let's see if I can just scroll this up a little bit here, we could say that the vector that starts here and goes to here is also the vector u minus v, given that that was u and that was v when we started. Do you think you could guess or maybe redraw this same little triangle if it was vector v minus vector u? I'm going to let you guys try it out. That's kind of evil looking. There we go. All right, there we have it. Two pretty simple operations.